Okay, yay, we're live! Woo! Okay, so hi guys, welcome. We're gonna be doing arrays today. So I guess we'll just get started on just talking like conceptually what an array is. So how much experience do you guys have with arrays?
I don't have a lot of experience.
Okay, so not a lot of experience. What about the rest of you guys?
I've had a bit.
A bit?
Mhm.
Okay.
Yeah, I have a bit too.
Okay, so I feel like for just in general, it's really good to have a really strong conceptual understanding. So the best way I feel like to describe an array is like, I don't know if this happened for you guys, but in kindergarten we had cubby holes. So the cubby holes are so small that you could only really fit your lunchbox in it. So it was like an allotment of space all in a row next to each other. You had little slots that you could fit your lunchbox in. So that's really similar to an array because the idea of an array is that it's a data structure or it's really just an object that you can place only one value in for each slot. So each element of an array will have one value stored into it. Does that make sense?
Yes.
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 Okay, so one thing important about arrays is that they are objects. So just like you can have like animal objects or you can have locker objects. Arrays are objects as well. So you have to instantiate them with a new operator and stuff like that. That's Hannah's gonna go more into that. But I know that was something that I really didn't understand for a really long time. And so I just wanted to make sure that you guys knew about that because I thought arrays were just like integers or they're just like any other old string. Well, strings are objects, but like they're like any other old like primitive type where you could just like you could treat them as such, but it's not the case. So now I'm gonna let Hannah take over with the actual syntax and so on and so forth.
Okay, so I'm gonna share my screen for you guys. Okay, can you guys see my screen?
Yes.
Yeah.
Okay, one sec. Okay, so now I'm going to show you guys what defining an array actually looks like in Java. So there are a couple of different ways that you can make an array. So the first way to initialize it is just like this. So you have whatever variable type you want the array to hold, followed by brackets, and then whatever you want to call the array. And then, like we were just saying, an array is an object, so you have to instantiate it as a new object. And so you just put the identifier new. And then you have your variable type again, along with in brackets how big you want the array to be. So you could also do this the same way by having on separate lines just creating the reference for the array, so just name, and then on another line actually instantiating it. And then the next way that you can make an array is actually putting values into the array directly when you instantiate it. So in this example, we have an array of integers called nums. And then in these curly braces, we're putting into the array the values 1, 4, and 3. And then on the next line, we have another example using an array of strings called names. And we just have the values in brackets again. And so some important things to know when using arrays is that the length of an array starts at 0, not 1. So let's say I wanted to access the first element of the nums array. So I would type in nums 0. And let's say that I wanted to change that first element, the 1, then I would just say num0 equals like 9. So that's a really important thing to know, that the indexing of an array starts at 0. You hear him? Anything? Oh, hello, you guys. Does that make sense? I think everybody's mic is on mute. Can they hear me? Can you guys hear me?
Yeah.
That makes sense.
Okay, that makes sense to you guys? Okay. Let's see, what else? Okay, so the other important thing is that when you want to access the length of an array, you type in nums.length, and that's going to return however long the array is. So for example, for the array nums, it's going to have a length of 3 because there are 3 elements. And so you won't get points off on the AP test if you do this, but a common mistake that some people make is thinking that dot length is a method. So they think that you need the 2 parentheses around it, but it's actually not. It's just dot length.
Yeah, I have a question, but when you use dot length for strings, you have to put the parentheses.
Mm-hmm. Yes, they're 2 different things because that dot length is a method that comes with the string class versus this dot length is just a property of the array. So that is something that you guys are going to have to try to remember.
Yeah, it's just like when I was saying that arrays are objects. So you know how like objects can have fields or instance variables? So one of the characteristics, or like Hannah said, one of the properties or the fields of an array object is the length itself. So that's why you don't actually need a method to access it. It's actually just a property of it.
Okay.
Okay, do you guys have any other questions so far? Or does that all make sense?
It makes sense.
Okay.
Yeah, makes sense.
And then the one other important property of an array to remember is that arrays can't change size. So once you instantiate an array to have a certain size, it stays that way. You can't change the amount of elements in it. If you want to have an array with a different amount of elements, you have to make a new array. Okay, I think that's it. So do you want to talk about iterating through arrays now? Common mistakes first. Okay.
Okay, so I'm just going to talk about some common mistakes that people make with arrays, because arrays are your first real encounter with storing variables or storing data in general. So I am going to share my screen for at least one thing that I personally did not understand. So I'm going to assume that it's a common mistake, but it probably is just me. So do you guys see the screen? I have the ebook pulled up.
Yes.
And okay, perfect. So one thing that a lot of times people focus on arrays for storing primitives. It's pretty simple because like in each slot of the array, in like the first element or second element, it directly stores a number. But when you can actually have arrays of objects. So in this example, they have arrays of strings. But if you make other classes like arrays of animals, arrays of giraffes, you can have like any sort of object in there. And so one thing that's really, really important to recognize is that when an array is storing objects, each element doesn't store the object itself, it just stores the reference. So what I mean by that is that it's not storing like the actual contents of the object itself, because that's in another area of memory called the heap. Inside each element is just the address for it. So you can, and that's how they're trying to describe it through this picture. Whereas in high scores, you can see directly inside the box, they have the actual numbers. So they have the actual direct values of what each element is storing. But in case of names where it's trying to store strings, it is not actually holding the contents, it's not holding the string object itself. It's only holding the address or the object reference to that string. So that's just something I wanted to clarify because I know I found that confusing at first. So do you guys have any questions before I move on to anything, I guess, a little bit more basic than that?
I have a question about the array.
Mm-hmm.
So you said when you set it a certain size, you can't change it?
Yes.
So is that like final integer? Like, you know how you say like final integer equals 5? You can't really change it?
Mm-hmm.
So it's like arrays considered like final, or?
They're not, if you say final array, it's very different than what you're trying to say. Your idea is right that once you set the size of an array, you can't change it. So in that sense, it's kind of final because you can't change it. But don't use the final keyword because that means something very different in relation to arrays.
Okay.
Yeah.
Definitely like
But the idea is the same, that once you have it a certain size, you can't be like, oh, I want to add more elements to the array. Let's make it from a size 10 to size 15 directly. You can't do that. We have some ways to get around it that we're going to be talking about today, but you can't directly do that. Any other questions?
So when you use like the reserved word final, is this like just for primitive types?
I believe for the most part they're used for primitives. I feel like I've learned once or twice in class that you could use it for objects, but that's not really something you need to worry about for the AP exam.
Okay.
That's more of like a very specified usage of final that you don't really commonly see.
Okay.
Yeah, no worries there. If that's it, I'm just gonna move on to some of the other common mistakes that people make. Just looking back at this as a reference. So yeah, Hannah actually covered most of it. The idea that array.length is not actually a valid index in the array because the array starts at 0. So if you have an array of 5 elements, it's actually going 1, 2, 3, 4. Sorry, 0, 1, 2, 3, 4. Oh my gosh. Instead of going 1, 2, 3, 4, 5. So it's just something to keep in mind that with computers, oftentimes you'll see. Ew. Sorry, I'm hearing interference. Sorry about that. So yeah, that's just something you'll see often in computer science, that indexing. So whatever you start off with the data structure is going to start at 0. Don't hard code any values. Those are bad. Yeah, I think Hannah really covered most of the common mistakes. So without further ado, I guess we can just start with one practice question first to see what you guys think of arrays. So I'm going to share my screen now. Here. So this question is actually very near and very dear to my heart because it was my AP exam question back when I took it in junior year of high school. So I'm just going to zoom in on it. Yep, so this is one part of the question. Let me actually zoom in a little less on it so you can see the whole thing. So this was from 2015, I believe. And so this was the basic premise of the question, and you guys can read it on your own, is that you have an array called array1, and you want to find the sum of all the elements in the array. How do you do that? So I guess take like a minute or two to think about it. Even maybe write some code on the side on a piece of paper so that we can all discuss it together. So just type done when you're done. Do the next practice problem. Or should we go straight into like moving back and forth in an array and resizing one?
What time is it? I mean, it's only been 20 minutes. I think maybe should we have them do like one more basic example?
Okay, so I guess you can do one of the
I
coding
have a question.
Okay, yeah, that's a good idea. Yeah.
Okay.
Do we have to do a for loop?
Excuse me, what?
Do we have to do a for loop?
We can talk about that. Just write what you think that you need to do.
Okay.
So let's just give it one more minute and then we'll talk about it.
And we're going to send all of these examples out to you guys if you want to go back and look at them later after we're done.
That sounds great.
Okay, so I'm going to stop sharing my screen if that's okay. Or do you guys want me to keep it up there as a reference?
Keep it up there for reference.
Okay, so how do you guys think this is going to work? Like, what do you think we need to do in order to accomplish what this method wants us to accomplish?
Write a static method. So would it be like private static void main? Like it would definitely have like the keyword static,
Mm-hmm.
and it would definitely be a method. So a method would it wouldn't have the parentheses or like for a parameter. It would.
Well, not necessarily. Sorry. You were right about the keyword static being there because it's saying write a static method. And I'm not actually sure. I believe they wanted it to be public, but that was something that was on the next page that I thought wasn't really necessary, so no worries there. But it actually says in part A that it returns a sum. And so because of that, the modifier is not going to be void. It's actually going to be returning an integer. So it would be public static int. And then the method name, so public static int array sum. And then it actually is going to have a parameter because it's going to take in an array. Because it's taking in as a parameter the array that you want to find the sum of. Does that make sense to everybody?
Can you repeat that
So-
one more time? Public static.
Okay, so for the AP exam, I believe they'll always want you to write a public method. I will double check on that, but like I've never had any instance where they wouldn't.
Yeah, and also for a lot of problems, don't they like already give you a method signature?
Yeah.
Like, I'm not sure if you actually even have to write a method signature. Do you?
I'm
I
not
guess maybe
sure.
we did, but
I'm not sure if they've changed that or not. So
that's good.
So this is what I tried.
oh, what
Can you
did you
see
tell
my
me?
screen? Can you see my screen?
Oh,
Oh yeah.
I guess
Yeah.
you can look at it.
Public static. Yeah, good job. The only thing, and this doesn't really matter that much, but you call, oh, actually, no, never mind. Just kidding. Yeah,
Okay.
it's good. Yep, good job.
Okay.
Well, Nate, how about you explain your how did you get that?
So I used for loop because we know how long the array is.
Mhm.
So to access each method, I've learned about it like recently, I think.
Mhm.
So you have to use a for loop to access every method in an array, and you have to add each method. You have to access it, and then you have to add each method like every loop you're making, and then return the sum.
Yep, you definitely have the logic right. Does that make sense to everyone else? Like the way of thinking?
No.
Yeah, no.
Okay, so basically, what Nate was doing and what this method is trying to do is you're trying to find the sum of each entry, right? And
Yes.
so what what I did actually for this exam is that outside of the for loop, I declared an integer named sum because that's what the number I want to return. I want to return the sum of each element. So Nate was perfect in saying that a for loop is probably your best bet, just because for for loops, like we mentioned last week, they're really good when you have a certain range that you want to run from. And in this case, we want it to run from 0 to whatever the last element of the array is. So it would go from like 0 to r1 dot length r1 dot length, because you want it to run from 0 through, in this case, 0 through 4. So does the bounds make sense?
Yes.
Yes.
Okay. And so because you want to go from 0 to 1 to 2 to 3 to 4, it makes sense to have I++. And so you're going to iterate through each element of the array, and you're going to take whatever the contents is of that element, and you want to add it to sum. Because sum is kind of like you're running tally, I suppose you could say. And so, for instance, for the first loop of this method, it would be taking whatever is in the 0th element of the array, so 1, and it's going to add it to sum being 0 at this point. And then we're going to take that value and store it back and assign it back to sum. So the statement as a whole would look like sum is equal to sum plus r1 bracket I. And so you're going to keep on doing that. And what that actually ends up doing is basically doing the 0th element plus the first element plus the second element plus the third element plus the fourth element, all the way up until the last element you have in your array. And then after you break out of your for loop, you're just going to return sum. Is that clear? Does that make sense? Because I can explain it again.
I have a question.
Mm-hmm.
So since you return the value, void is not there. So I remember you were saying it was public static integer, right?
Mm-hmm.
So you would just have the reserved word, and void is not a factor anymore. So
Yes.
That's how a value can be returned, right?
Exactly. Because void just means that there's no return value. If you have int or double or float or string or kangaroo, it'll return that type.
Wait, what's kangaroo? That's
It could be a type of object.
oh, I thought it was a reserved word.
Yeah, so like if you defined a class called kangaroo.
Oh. So if you ever wanted to write an array, you have to use a for loop first, right?
You don't necessarily have to use a for loop. It's kind of what the better option, I feel like.
Mm-hmm. Like what we were talking about last week. Can you still hear me like through that computer? Because it's just like the echo.
Oh.
Can you hear me like talking?
Yeah.
Yeah.
Can they hear me?
Yeah, they can.
Yeah. Okay. So like what we were saying last week, whenever you use a for loop, you want to use it if you already know what value or like how many times you want to iterate through it. And since arrays, like we said, have a fixed length, if you want to go through the whole array, you're always going to know exactly how many times you want to go through it. So that's why a for loop is usually the best option. Does that make sense?
Yeah, I have a question.
Mm-hmm.
So if you're like in the for loop in the parameter, you say I plus plus at the end, and I think that's to iterate through the loop. So you do sum equals sum plus 1. Like, what are you doing in that sense? Like, if I is iterate, if you're incrementing to go through the loop, then what is sum equals sum plus 1 or sub I?
It might be easier actually if I just type it out. So here I'm sharing my screen on Eclipse. Let me just make a new file. So like we said before, it's going to be public static int sum array, and it's going to take in an integer array, right? So that's clear. So I was saying earlier that you want to declare an integer named sum, just so that you can keep track of whatever the sum of the array is. So it's just easier to see. So we're going to initialize I to equal 0, so that it starts off at the 0th element. We're going to go until I is less than array1.length. So that means within these bounds, it's going to go from I is equal to 0 up until I is equal to the array length minus 1 because of the whole less than thing.
Mhm.
And then I++ is going to actually go here inside the initial, like the parentheses part of the for loop. So that's where you increment into different elements. So within the body itself, you're going to do sum is equal to sum plus r array 1 I. So sorry, I'm just going to put the return statement and then I'll explain. So basically what this inside statement here is doing is that it's going to take whatever value you initially had in sum. So in this case, if we're running through the loop the first time, it's going to be 0. And it's going to take whatever value is in array 1 and whatever I is. So if we're going through the first loop, since I is equal to 0, it's going to take in whatever value is in that array. It's going to add them together. And since this is an assignment statement, it's going to take whatever value you had here and place it back into sum. So sum is going to equal whatever the, so in this case, I think it is 0 and 1, looking at the original problem. And so that's how you end up like getting the sum, and that's how you format the answer. Does that make sense?
Yes.
Okay, cool. Sorry, I feel like I rambled a little bit there, so I wasn't sure if I was actually hitting your question.
No, it made sense. Thank you.
Okay. I will copy and paste this code later so that you guys can use it as a reference. So I guess if there's no other questions, we'll move on back to Hannah, and she's going to do a coding that problem.
I have a question.
Oh, sorry, yes?
What does I represent? I saw like you wrote like integer I, but was I like just a variable you guys made up, or it was
I is technically it's like a counter variable.
a counter?
So in each for loop, you're going to have some int like some integer and some int number is equal to something. So that basically controls how many times your loop is going to run. So in my case, I had it set from I is equal to 0 to I is equal to array length, so that it's going to run from these certain values.
That makes sense.
Okay. Okay, cool. So
Yep.
yeah, Hannah's going to take on the next practice problem.
So I'm going to send you guys the link to a problem on coding that. And so first I want you guys to actually try coding this on your own on your computer. I just sent it in the chat. And then in a couple of minutes, we'll go over it as a group. So did that link work for all of you?
Yes.
Okay.
It worked.
Okay. So when you think that you're done, you can just type in the group chat, or we'll just go over it in a couple of minutes. I'm going to type it out too. Yeah, I think so. Okay, does everyone still want a couple more minutes? Or are you guys
Yeah.
stuck?
One more minute.
Yeah.
One more minute? Okay. Okay. Do you guys want me to go over it now?
Yes.
Yes.
All right. So, oh wait, I need to share my screen. Okay. All right, can you guys see my screen? Yes?
Yes.
Yes.
Okay. So here is the code that I used to make it work. So the first thing that I did was declare a variable. Oops, sorry about that. I declared an integer variable called num2s, and this variable is what I'm going to use to count up all the 2's that we see in an array. So like we said earlier, when you want to run through all the elements of an array, your best bet is usually a for loop. So just like we did in the last problem, we're going to declare an integer I equal to 0. And the for loop is going to run as long as that variable I is less than our integer array nums, the length of it. And each time the for loop iterates through, I is going to increase by 1. So then within that for loop, we have to check every single element to see if it's a 2 or not. So I have an if statement that if in the nums array, sorry, my screen keeps moving. If in the nums array, whatever element you're on, so the one with an index of I, if that is equal to 2, then I'm going to add 1 to that variable num2s that I'm using to count how many 2's appear in the array. Does that make sense to you guys so far?
Yes.
Yes? Okay.
Yes.
So that loop is going to run all the way through the array. And so now we have to check to see if the sum of all those 2's is exactly 8. So to figure that out, I have another if statement. And so what I'm going to do is multiply that integer num2s by 2. And if that is equal to 8, then it's going to return true. And if it's not true, it's going to return false. Does that make sense to you guys?
Yeah, it makes sense, but I did it like a little differently, and I got it correct.
Okay, yeah,
You wanna see
you could do
mine?
it a little bit differently, yeah. If you want to put it up on your screen, and you can explain to everybody how you did it.
Okay. So can you see my screen now?
Yep.
Okay. This is what I did. So I declared an integer variable called sum to collect the sum of 2's. It's kind of like a weird name, but I should have named it sum of 2's instead. But it worked. So I did a for loop to go through all the indexes, and each index I went to, I checked in if the number stored in that index is 2 or not. So if it's 2, it's gonna add up 2 to the sum over here. So at the end of the loop, when it finishes, if it's 8, it's gonna return true. this is like a condition. So if sum equals to 8, it's going to return true. And if it's not, it's going to return false.
Yeah, great job. That's a really great solution. And it's even shorter than mine is, which is good. So
Okay.
yeah, that's a really good job. Does everybody understand how he did it?
Yes.
Okay. All right, so I think now we're going to move on to another example. If you guys all understand that, should we do making bigger or making smaller first?
I guess making smaller.
Making smaller, okay.
Okay, so we're going to go into something slightly more complicated, so feel free to like ask us questions and stop us, because this is something that I know, at least for me, I struggled with a lot. And so, like we said earlier, arrays can only have a defined size. When you initialize it to a size of like 8, you can only keep it as that size. You can never make it smaller or make it bigger. But obviously, as computer scientists, we don't like boundaries, so we're going to mess around as much as we can to get around it. And so one of the ways that you can get around making an array, or one way you can get around the fact that you can't change the size of an array is that you can remove elements or you can add elements, and all you would do is just make a new array basically of a bigger size. So I'm just going to share my screen and show you what we're going to look at. So our goal here is that let me make this a little bit bigger. We're going to create a method called toRemove, and it's going to take an array and an integer called toRemove. So that number toRemove is basically the last instance of a value you want to remove. So for instance, it's easier to look at an example. So say I passed in this array with these values. 1, 2, 4, 28, 482, 29,121, 12, and 2. Wanted toRemove to equal 28. So that basically means I want to remove it from the array, and I want the method to return this array, which is basically the same thing, but the 28 isn't there anymore. So technically, if you think about it, we're kind of making the array smaller or shrinking it because we're taking away a value. But in actuality, all that we're doing is we are taking the array you give us as a parameter. We are only the elements we want to be copied into the new array, and then we're going to return that array. So originally I was going to ask you guys to help me out in making this, but I think we're a little bit pressed for time, so I'm just going to go straight into the code for it. So bear in mind there's a lot of different ways you can do this, but this is the way I came up with, and I feel like it's the easiest to understand. So what we're doing, right, is we want to create a method that is going to remove one integer. And that one integer is the last occurrence of a certain number. So we're going to make a copy array that is going to be the same size as the array we passed in minus 1. So it's just going to be one smaller. Does that make sense before I move on?
Yes.
Okay, cool. So we want to find, so say toRemove is equal to 3. So what we want to do is we want to look in the array and find the 3 and find the location that it's at. So if we're looking at this example, we want to find the location of 28 in the original array so that we know which location we want to take out. So in this case, it's 0, 1, 2, 3. It's at index of 3. So that's what basically we're going to try to do. We're going to find the location. So to do that, we're going to do a for loop, and it's going to iterate through the entire array, and it's going to be like, okay, so if the element that I'm at has the same value as the number we want to remove, we're going to set that location to a variable that I called location up here. And just so it's clear, I only called it -1 so that just in case the number toRemove is not actually in the array. So say if I asked you to remove 100 from this array, the location would say -1 because I'm saying it's not even in the array in the first place. So it's just a little check, some error checking in there to make more robust code. Does that make sense? Before I move on to the next section?
Yes, it makes sense.
I'm a little confused.
Okay.
I'm very confused.
About what section? Um,
In terms of like, so you said if the array
Mhm.
is equal to I, set the location to where I is, but you
yes.
set the location to -1 because
Basically, that's just in case. Say the number that we're looking for is not actually even in the array.
okay.
So I'm basically saying that like if we set initially the location to -1, and that number is not even in the array in the first place, it's going to go through this for loop, and the location after the for loop will still equal -1, because it wouldn't have been changed because the number we're looking to remove isn't even in the array in the first place.
Okay.
And so that kind of ties to like the next little block of code I have here. So if the element wasn't even in the array, it's just going to return null.
Okay.
So that basically is just like, yeah, there's nothing to change here. Does that make sense?
Yeah, that makes sense.
Okay, cool. So sorry for rushing this a little bit. So now by this point, if the location is greater than 0, that means we know where the location of the remove element is. So in our example back here, we know where the location of 28 is. So what we're going to do is something a little bit complicated. So we're going to have two kind of counter variables running. We're going to have the counter variable for the copy array, and we're going to have the counter variable of the original array. So that's why I have index of copy here and index of original here. So we're basically going to go through each element of the original array, and we're like, okay, so if the index of the original array is equal to the location of the element we want to remove, we just want to skip over it because we don't want to copy that element into our array in the first place because we want to remove it. So we want to like kind of push it out of our mind, remove it from existence. So the idea of skipping over something is just like incrementing it one more time. And so if we're looking at this example over here, the effect it would achieve would be like, okay, since we know the location variable would be equal to 3, since 0, 1, 2, 3, once we hit that point, it's going to be like, LOL, now we're just going to go to 4. So what it ends up happening is that it'll just completely skip over that element that we want to remove. And so afterwards, you're going to take whatever the value was in the original index and put it into the copy index. Or sorry, put it in the copy array. And then we're just going to increment index of copy by 1 because this is basically our counter variable so that we can keep the indexes of the original arrays separate from the indexes of the copy array. And so does that make sense? I know it's a bit confusing.
You lost me. Not gonna lie.
Let me see if I have a piece of paper with me to explain this.
You want to write on the whiteboard?
Oh yeah, that would work. Okay, so I'm gonna stop screen sharing for a second. So yeah, thanks, girl. So I'm just gonna use the whiteboard back here. Hannah's gonna help me. So.
Do you mind if I take this out? Okay.
Why do they have a chalkboard eraser? Not a whiteboard. Okay, so what we're doing here is like I just made an example of the thought process for this code. We can go over the specifics of it during a one-on-one session. Basically, here's our old array. So this is the one we want to change. And say we want to remove 7 from the array. So you know instinctively that you expect this new array to have 3 and 4 here. So like that's the values we want to keep in here. So what I'm saying that we do in this for loop is that we're gonna have the counter variables for the old array separate from the counter variables of the new array. So it's basically that we just want to keep how we're incrementing them separate. So we're going through the loop in different ways. So that's why I have index of original and index of copy. It's because I don't want them mixing with each other because they kind of leads to messy code. So what I'm basically saying is that, okay, the location of the element we want to remove is 7. And so we know the location of it is 1. We're saying that, okay, if we look at the old array and we're incrementing through the whole array and the location is equal to 1, we just want to skip over it and have it equal to. And so what this ends up doing is actually skipping over the element we want to remove, and it will never copy it into the new array. So if we're looking at this practically, it's going to start off with element is equaling, with the index equaling 0. And so it's like, okay, 0 is not equal to 1. So we're just going to copy this value right here. So new is going to equal 3. And we're going to increment old. So it's going to be like, okay, 1 is equal to 1. And that's the location we want to remove. So we're not going to do anything. And we're going to skip up until 2. So now, because we kept our variables separate, it's going to be like, okay, so now we want to copy whatever is in 2 into 1. And so that's how that's essentially what the code is doing in this portion. We're running a bit out of time. So if this isn't making any sense, please sign up for a one-on-one session so that we can go over it more thoroughly, because I really want to cover making arrays bigger.
Okay.
And talking about making them bigger, it's pretty similar kind of thought process. So that might help you guys a little bit to see that. It's okay. Okay. So I was going to have you guys talk about this problem first, but I don't think we have enough time. Okay, so I just have the problem that we're going to go over typed out in the chat. So a customer at the supermarket can add as many items as they want to a shopping cart. And so we're going to write a method called add item that adds a new item to a shopping cart represented by an array. And this problem is how my computer science AP teacher taught us how to increase the size of an array. Okay, so if you guys look at my screen, yes, okay. All right, so in I am making a array of strings called shopping cart that's going to represent our shopping cart, and I'm just setting it to say that it has 5 items in it. And so then I have an item that we're going to put in the shopping cart called cereal later. But so first, to show you guys what happens if I'm not screen sharing anymore.
Yeah, you're not.
Okay, 1 second. Can you guys see my screen again?
Yes.
Yep, I see it.
Okay. So just to show you guys, we're going to, just like in a for loop like we did earlier, we're going to quote unquote fill the shopping cart with bananas. So for each index of our shopping cart array, we're just going to add the string banana into it. Does that make sense?
Yeah.
So then here, I'll show you guys. So then when you go through those lines of code, you can see first we just have our array where all of the 5 elements are null, and then we're going to fill each slot with banana. You guys see that?
Yes.
Okay.
Yes.
So then we're going to go into our method because we want to add this item cereal into the shopping cart. So now I'm going to show you guys that method. So I declared public static string because it's going to return a string array. And the parameters for this, like we saw earlier, it's just our shopping cart array. and then the item that we want to add to it. So like I said, we want this method to be able to add an item to the shopping cart, even if the shopping cart is already full. So even if the array already has as many elements as it can in it, we still want a way to add another thing to the array. So we're going to use the same idea as we did in the previous example, and we're going to create another array called temp, and basically it's going to have double the length of the original shopping cart, so we can add another element to it. Does that make sense to you guys? Sorry, I'm going through this kind of fast just because we're low on time.
Yes.
Okay. Oh, and then, oops, sorry, I skipped the line. Okay, so then this if statement is basically just saying, so shopping cart dot length -1, that's going to access the last element of the shopping cart. And so if that element is not equal to null, then that means that the shopping cart is already full. The array already has all the elements that it can fit into it. And so then that's when we're going to go into this and create that temporary array to add more elements into. So then in this for loop, we are taking all of the elements in shopping cart and we are copying them to the temporary array. Does that make sense to you guys?
Yes.
Okay. So then after we copy all of the elements from shopping cart into temp, we are going to go into the very last element of our temporary array, and we are going to put our item in there. And then we are going to take our shopping cart reference and we are going to change it to equal the temporary array. So I'm going to show you guys visually what this actually looks like. So, okay, we're going through the array, we're filling with bananas again. Then we're going into our method. And so, okay, so we have this new array temp that is double the size of our original shopping cart. And then so for each element in shopping cart, we're going to copy that into temp. So you can see that filling up with the bananas, so it looks the same as shopping cart, but then since it is double the length, went too far, but then since it's double the length of the shopping cart, we're going to have all these spaces that are now open to add more elements into. So then we are going to add that cereal, the last element, into our temporary array. And then we are changing shopping cart to point to that temporary array instead of to this original array. And then we're just going to return that shopping cart. And so then if the shopping cart wasn't full, then we would just go to this, our else, and we would just add that item to whichever index does not have an item yet. So does that make sense to you guys?
I didn't understand how you added the cereal when you copied it over.
Okay, so when we add the cereal, let me get back to it. So that's this line here. So we're taking our temporary array and we're accessing the last element of it. And, or sorry, okay, we're not accessing the last element of the temporary array. We're accessing whatever the index of the original shopping cart array is +1, because remember, shopping cart dot length is going to be equal to 5 since there are 5 elements in the array, but since it starts at 0, it only goes up to 4.
Yeah.
But then when we go to our temporary array, now it has those spaces in it, so we can add that cereal after all the bananas.
Okay.
Does that make sense?
So yeah, so item is the item is the cereal.
Yes, item is the cereal. That was just the parameter that passed into the method in main.
Okay.
See, shopping cart equals add item. And
Okay,
then that
yes, I got
item we declared here. Okay. Any other last minute questions? And if you guys really don't understand this example, we can go over it during a one-on-one session. But does that mostly make sense to you guys?
Yeah.
No, I'm completely lost.
You're completely lost.
I'm
Sorry,
a
this
little.
is something that takes a long time to go over, so it's really hard to go over in 1 hour. It's something that like me and Hannah have spent weeks on in class.
Mm-hmm. But so yeah, you guys
Yeah.
can definitely sign up for a one-on-one session, and we can go over it again.
Okay.
Yeah, that'll definitely help. This just tells me I don't know anything about Java if I can't do that. So
That is
I got-
not true.
Girl, we started with like no knowledge whatsoever, and all of like the only difference between you and me is just that I've spent more time learning it than you. That's the only difference. I'm also
Yeah.
older than you, so keep that in mind. So
it's just everything is accelerated, and it's just in our computer science class. It's just very weird. Like our teacher, she be trying to teach us, right? But I don't know. Just it's complicated. Just that class. Well, it's not like complicated. It's just not teaching efficient enough, and
Well, that's
Just
what
so
we're
many-
here for.
yeah, you guys help a lot, and it's just so many concepts I have to learn by myself. But you guys help a lot. You guys
Yeah,
really,
it's a lot, but it's also really great that you really want to try to understand it for yourself.
yeah,
And if you
Yeah.
put the effort in, then you will. It just definitely takes a lot of practice at first to understand.
yeah. There's definitely a learning curve with computer science that you understand it. You finally get things once you're in like the middle of it. Like you kind of just have to take a lot of things for granted and just accept what the textbook has to say. But once you've gotten past that point, then things will make sense.
yeah.
Trust us. It happened to us, it'll happen for you as well.
Computer science requires a shift in consciousness. It's very deep.
Yep, that's for sure.
I have a
Yeah.
question.
Um,
I know you can't sign up for one-on-one like back to back, but can you do like more than one in one day? Like it doesn't have to be the same person, but like if you just kind of like need clarification, like
yeah,
for a long
you can sign up for at most 1 hour at a stretch.
Okay.
So that means just like you can't sign up for like 2 hours of one-on-one tutoring, but you can split it up between people.
So you
People.
can
Okay.
set 2 slots in a row because the slots are 30 minutes each.
Yeah.
Okay. Oh, okay.
So
does
you can
that-
have,
Oh, sorry, go on.
so you can only have one person for 1 hour, right? That's the limit.
Yeah, basically.
Okay.
Okay.
And then also something that's just important that Kate is going to be sending you guys an email about is that please try to give us like at least 12 hours in advance, whether you're going to cancel or even if you're going to sign up, just because that like all of us are really busy and sometimes we don't check our emails. I know that happened to me yesterday. So we don't want to have it that you signed up for a tutoring session and we just happen to not check our email within the past like 3 or 4 hours. And it turns out you guys were waiting for like us for an hour, but we weren't there because we didn't see it. You know what I mean? So it's just better for all of us if you sign up for like at least 12 hours in advance and also cancel it at least 12 hours in advance as well.
Okay.
Okay.
I think that's the only really thing that we needed to say. So we hope you guys have a really good day and a really good night, rather. Once again, if you have any questions, feel free to sign up for any one-on-one tutorings with me, Hannah, Steven, any of us.
And we're also going to do this same exact webinar on Saturday. So
Mhm.
if you really didn't understand this and you want to go over the exact same thing again, then you can do that on Saturday.
Okay, that's
My 132 professor says that repetition is very important to learning and that the more times you hear something in different ways, the more you're likely to understand it. So feel free to come on Saturday as well.
Okay.
Yep.
Okay. How do you sign up for the one-on-one thing? I'm sorry.
I believe it's on the Google Calendar that Kate shared with you guys.
Is it
Or
on
just like the
the
project
email?
myself.
Yes.
Oh, okay. I never got it. Let me try to see it again.
Okay. If you can't find it, then you can just email us and we can try to send it to you again.
Yeah.
Okay.
And then after that, you just click on the slot that you want, and basically that sends us an appointment, so we can accept it from there.
Okay. All right.
Okay, cool. If that's it, we're just gonna wrap it up today. So
Hey, are you gonna
see
put it
you
on
guys.
YouTube?
Yes, this will be on YouTube.
So it's like as soon as we cut off, it's gonna be on YouTube, right?
Yeah. Well, there
Great.
might be some processing time in between, but
Yeah.
Yeah.
Yeah, I hope it's
Yep.
low. I wasn't able to finish watching the first video, but I should just watch all the videos. And that should just help. And it's just very hard to do the one-on-ones during the weekdays because school just be busy and all these different
Mhm.
factors and the push and the pull of different forces. It's just
yeah,
very hard.
we understand.
Yeah. Weekends are just better. It just helps.
Hmm.
I think there might be a couple of one-on-one
On the
times
weekends.
On weekends.
Yeah.
Maybe Steven might have
Yeah.
some weekend time.
I believe he has, yeah. And I know I have him on Sundays. So, yeah. So, we'll just call it a night then. So, see you guys. Have a good
Good night,
week.
guys.
Yep.
Yep.
Bye.
Alright.
Bye, guys.